Assalamualaikum to Professor Madya, Dr. Khairun Nidzam bin Ramli, and Professor Madya, Dr. Rozlan bin Alias. My name is Muhammad Arif Bin Nordin with metric number HE190006. For this video today, I will present my proposal defense for research of a fundamental study of electromagnetic interference effects from Malaysia railway system towards cardiac pacemaker functionalities. This research is under supervision of Dr. Syarfa Zahirah Binti Sapuan. For research introduction, the development of public transportation in railway system in Malaysia is consistent throughout the years in 90s, especially in populated area in big cities such as Kuala Lumpur and Selangor. The efficiency of the train led to the increase of passengers. In today's world, with rapid development of technology, contribute to the source of electromagnetic field, and the complex railway environment is one of them. First of all, for the introduction, pacemaker is an implantable medical device that can help to manage irregular heartbeat through pacing and sensing by the leads. Like many other devices, pacemaker can be affected by the EMI, which can cause several dysfunctions to program settings such as synchronous pacing and inhibition pacing in seconds. This is a concern for passengers, especially for a pacemaker-dependent patients. With the continued aging of the population, the demand for pacing services is likely to increase. This led to several research concerns such as to what level of EMI can be produced by the railway system and if it electromagnetic compatible to support the safety of passengers. Therefore, the objective for the research is to calculate and measure ambient radio frequency signal from actual railway environment. Second is to study and analyze the standards of radiated emission fields at railway environment. And third is to analyze the EMI radiated from the railway system that exceeds the minimum immunity of pacemaker sensitivity setting. The scope of the research focuses on the pacemaker immunity that based on the calculation of sensitivity setting obtained from the equation provided by the standards. Second, real measurement will be done at most vulnerable railway environment. And lastly, the result will be compared to analyze if it exceeds the pacemaker immunity at the lowest sensitivity setting. For literature review, actually, modern pacemaker is incorporated with filter and isolation circuit to provide shielding to the pacemaker. But EMI can still be affected through the pacemaker leads that function as to pace and send electrical signal. This is because they are implanted on the conductive body tissue and form the rhythm parts through the medium. Basically, pacemaker has two types, which are unipolar and bipolar, and due to the difference of design, it has two different inductive loop area. As we can see from the figure, it shows that unipolar pacemaker inductive loop area is larger than bipolar, and this makes the unipolar vulnerable to EMI. First of all, pacemaker have generic code that can be programmed to pacemaker depends on the patient condition. The first code is for pacing, the second is for sensing electrical signal, and the third is to triggering or inhibiting pacing at chamber 1 based on the signal received from second chamber. If it's sensing an artifact signal or myopatential on that area that came from unwanted physical activity or EMI, it can give several responses to the pacemaker such as sensing and pacing inhibition or noise reversion to asynchronous pacing. For example here, due to the EMI, the oversensing by myopatential signals leads to the absence of pacing spike on the ventricle. This condition is called a systole in pacemaker-dependent patient, which is a condition where the absence of ventricular contraction. The other example also shows the EKG recording that shows the EMI could be sent as intrinsic ventricular activity, driving to oversensing event and pacing inhibition. For example, here, due to the interference of magnetic field at power line frequency, pacing inhibition occurred and complete atrioventricular block recorded during exposure. But normal setting program of DDD resumed when exposure to the magnetic field was interrupted. For this slide, we can see at the above figure is the normal pacing rate. For the below figure, we can see the pacing inhibition without noise reversion during the arc welder activation. where the cable of the welding system was placed over the shoulder of a phantom. The condition here is a patient with VVI program setting developed pacemaker inhibition during the 14 seconds following the ringing of the phone. Here is the limit standard for the exposure of EMI from several standards such as ICNIP, but this standard limit do not consider the patient with implanted medical devices such as pacemaker, since the interferences can arise because of both magnetic field and electric field through the induces voltage in the leads between the device and the electrode of the heart. The sensitivity setting of the pacemaker is important to know the immunity of pacemaker from interference. As you can see here is the several measurement and analysis of electromagnetic fields from train at other countries. The measurement is varied through the types of train power supply such as 600 VDC, 750 VDC, and 25 kV AC of 50 Hz mainline railways at different locations on the train. For figure 2, the average minimum of magnetic field is vary but slightly different depends on the location. For figure 3, the measurement result of magnetic field near the 750 volt DC measure moving train at 10 meter from the track is complied with European standard except at the frequency of 19 MHz. For figure 4, the measurement during the start of electro inverter train is at its higher at 50 Hz frequency. The methodology for this research will have 5 stages, which are the pacemaker immunity, electric field calculation, magnetic field calculation, real measurement, and analysis. For the first stage, the pacemaker immunity will be calculated based on the equation provided by the standard, where the sensitivity setting of 2 mV and 0.2 mV are selected for the worst case scenario of unipolar and bipolar type of pacemaker. Second and third stages will be the calculation of the electric and magnetic field for the train antenna, equipment, and transmission line. The fourth stage is where the real measurement will be conducted and selection criteria for the environment will be for most vulnerable area that can have EMI sources such as substation and transmission line. Lastly, the analysis will be done to compare the result if it exceeds the pacemaker immunity. The slide here shows the pacemaker immunity that have been calculated for unipolar and bipolar pacemaker at certain frequency level, which from low to high frequency. The range of frequency from 5 MHz to 450 MHz will be done for unipolar since, according to some research, the bipolar pacemaker design is 10 times more immune to EMI than unipolar pacemaker. For conclusion, any patient with pacemaker should not normally experience interference from low-frequency sources unless they receive specific warning from their physicians that their device implantation is exceptionally susceptible to interference. However, there are situations where the field can be larger than public exposure reference level, and for this research, it is necessary to understand whether or not interference takes place if based on the pacemaker sensitivity setting, which is the minimum myocardial voltage required to be detected by leads. The lower the number of sensitivity setting, the more sensitive the pacemaker. And this is the source of reference. And this is all for this proposal defense video. Thank you.